Okay, let's take a look at today's lesson. So we're going to be working with factorials today, and we have worked with factorials some in the past. When we were working with, probability, remember that, combinations and all that kind of stuff, we used factorials. And I understand that you did use factorials last year. You learned a lesson on factorials last year in Algebra 2, so maybe this is a review for you. I might be doing it a little differently than we did it last year, and so I'll show you a couple of different ways that we could do this. So first of all, let's talk about what we're dealing with. Factorials are products, and it's just like a shortened form of writing a particular product. So in factorial, we know means this. Something quite unusual. I know we believe we've talked about that before, that 0 factorial is 1. That's just really like a definition. If you want to see, I'm sure there's an elegant proof of it that you can find on the internet if you want to look to see why 0 factorial is 1. But it is. So if you see a 0 factorial, it's just 1. So this portion right here, these expansions, are what is going to help us simplify factorials. We're going to expand things out. Let's talk about the expansions. So what we typically will do is we start with like a 1 times 2 times 3. You don't need to put the 4, but we need at least 3 terms to show a pattern. So 1 times 2 times 3. Then dot, dot, dot. That means there's a bunch of stuff in between. And if this is our beginning place, what we want to do is we want to expand inside, right? We want to go this way. So if this is where we're going to end, what would we do previous to that? So let's think about it numerically. Let's just pretend that n was 10. Okay, if n was 10, and I wanted to be 1 back, because we know it's 1 times 2 times 3 times 4, 5, 6, 7, 8, 9, 10, right? So if I wanted to be 1 back, what would I do? Well, I would take 10 and subtract 1, right? That would give me 9. And if I wanted to be 2 back from 10, I would subtract 2, right? That would give me 8. So is we okay with those, the way that's sequenced? All right. So we also are going to deal with a little bit unusual ones, like with the 2n. So how would we expand that one? Still, we start with 1 times 2 times 3, and then dot, dot, dot. This is our ending place at 2n, and then we're going to go backwards to 2n minus 1, 2n minus 2. Same scenario. We just keep going back like that. So let's talk about what we're doing. What we're doing is we're preparing for using and simplifying these factorials in calculus. We actually, with convergence testing, we use factorials, and we have to simplify them, much like this. So we're learning the skills that we're going to need to, be successful. So you'll already know how to, and you probably already do know how to simplify factorials. So let's make sure we are good to go for next year. So this is an example of simplifying factorials right here. Notice what they've done. They've stopped here at this ending point and the ending points, and then they've expanded inward. Okay, so what our goal would be is to expand inward so that we could cross everything out. So notice in the second step, they're basically going, so what I like to do is look for the smallest one. Is the smallest one in the numerator or denominator, the smallest factorial? We would look for that. So how do I know what's the smallest? Well, if you're not sure, think about n being 10. If n was 10, which one of these would be smaller? Well, the bottom one would be, right? Because the top one would be 12. So this is the one I would expand it 1 space to the left is what I would do, the smallest one. Then the larger one, I would expand all the way, like they did, to that same spot, so that I could cancel everything out, right? So I cancel all those numbers out, all that goes away, and I'm left with this. That doesn't have a factorial, so our goal is to get rid of the factorials. All right. How are we with that? Okay, so I'm going to show you this technique on the next slide. I will also show you the technique, the other technique. There's lots, of course, we know there's more than one way to do things, right? That's the great thing about math, is there's more than one way to do things. And so we will look at the technique that is demonstrated here, and we'll also look at a different technique that I think y'all were demonstrated last year. Alright, so let's start out with the technique that I'm talking about right here. So what do? We look and see, okay, so we see which one of these is smaller. Okay, the bottom one is smaller, right? So that's the one I'm going to work on expanding. So I started at 1 times 2 times 3 dot dot dot, because that's just the way they all start. 1 times 2 times 3 dot dot dot. We have to have a beginning and an ending place. We can't just start in the middle and say dot dot dot. So we have that. So this is the smallest one, and I'm going to go 1 to the left of that one. 1, so this is n minus 1. What would be right to the left of n minus 1? N minus 2, right? To the left would be n minus 2. So n minus 2, n minus 1, and we stop. Okay? So I'm just doing the expansion like the technique that was on the other slide. Then I'll show you the other technique that we were looking at, or that maybe y'all looked at last year. So in the numerator, I want to expand this left as far as I did this one, just so it'd be convenient to cancel stuff out. Okay, so I start 1 times 2 times 3 dot dot dot. So I want to start way back at n minus 2, and then n minus 1, and then n plus 1, and then n plus 2. Okay, how is that? So we have expanded. Of course, we could expand this to infinity, right? We could go crazy expanding this. But that's really all we need is to, one left of the smallest one, and then just expand the bigger one to the smallest one, and then we can just, get rid of stuff, right? All that's gone. And so I'm left with n times n plus 1 times n plus 2. Okay. Now let's look at another option. Perhaps this is the option that you learned last year. So one other thing that you could do, so this is just a different technique. Wow, I wish I could reach that. Okay, so let's just look at this different technique. And either is acceptable. I'm not really picky, right, about how the techniques, as long as we're showing our work. So in the other technique, we start with the smallest one. Okay, and we actually leave the smallest one alone. And then what we do is we expand this one from the smallest one up. Does that make sense? And that's kind of weird. So we would have, we would have n plus 2. We're going to go down. So n plus 1. Then we would have n. And then what would we have next? We would have n minus 1 factorial. Right? And then we can cancel the factorials out. That's another way to do it. It doesn't, either way you like is fine with me. Okay, what I'm going to do, I'm going to be demonstrating this way every time because that's just the way that I'm used to. It's perfectly fine for you to do it that way too. Okay? So, 2 different techniques. Take your pick. Alright, let's look at the second one. So I look at these and I see which one is the smallest. 2n is the one that's the smallest. So I'm going to expand it 1 space left. So we're working on the numerator. So that would be 2n minus 1, and then, oops, I got to do the 1 times 2. This fun part right here. 1 times 2 times 3 dot dot dot. Okay. And then we have so we're going to go left 1, so that gives me 2n minus 1, and then 2n. Okay. On the bottom, 1 times 2 times 3 dot dot dot. And then I'm going to go expand this all the way left until I, match up with this. So 2n minus 1, 2n plus 1, 2n plus 2. So I'm left with 1 over 2n plus 1, 2n plus 2. Now actually there is a third way to do these. You're like, no, stop, I don't want to know more than one way. I don't want to know a third way. Actually, as you have more and more practice with these, you might just be able to, go straight to the answer. And that's where we'll get in calculus, is where we can just simplify it straight to the answer without anything in between. Okay? So last one, we need to rewrite this one. This is n factorial squared. So n factorial, n minus 1 factorial, n plus 1 factorial. Okay, so that's what we're dealing with. So the smallest one is this one. I'm going to expand it one space left. So I have 1 times 2 times 3 dot dot dot. Okay, so that would be n minus 1, n minus 2, n minus 1. Stop. Okay? So this one, 1 times 2 times 3. This one I'm going to expand back to n minus 2, n minus 2, n minus 1, n plus 1. I'll pause there for a second. Are we okay? Okay, so in the numerator, I'm going to expand these to the n minus 2. So 1 times 2 times 3 times n minus 2, n plus n minus 1, n times 1 times 2 times 3, n minus 2, n minus 1, n. Whew. Okay? It's a lot of expansion, isn't it? But see, isn't it just so satisfying that we can cancel stuff out? I so love canceling stuff out, making it look neater. I mean, don't you? It's so fun. So that goes away, that goes away, that goes away. Okay, we're left with an n over there. Okay, that goes away. Gone, gone, and gone. So it looks like what we're left with is an n in the numerator and an n plus 1 in the denominator. So n over n plus 1. Which makes it particularly nice to do this technique, so you just get to cancel, cancel, cancel. That's why I like. All right, are we okay with that? Okay.